Good morning, everyone. Welcome to another episode of Xa Talk Show. We're gonna do Wolfram language coding geometry, okay? Geometry, Wolfram language coding, Mathematica. And my keyboards, Glove 80, fantastic. Ultimate hacking keyboard, fantastic. Nulia trackball, and this is coming soon. This is Svalbard, Svalboard. This is hardwired. So I press a key, So for each one of them, I have a YouTube video review. So check them out. I'm gonna hop onto the Svalbard. Hello Mo, from Arab. Hello Diego. So I'm excited for the Asian shapes. What Asian shapes? So okay, so I guess we're gonna start to do coding then. Begin. Shall we begin? Okay, fantastic, beautiful. Emacs showing browser, perfect system. So I'm using Sapphire keys. So again, bear with me. 2 minutes introduction. Sapphire keys. This is a key binding system, key system for Emacs. Emacs is the greatest, most powerful text editor. And go to this URL showing browser. This is Sapphire keys. And so there's a video you can watch, and this is the key binding, so you don't have to hold Control, hold Meta, hold Alt, something, fuck up your hands, cripples you. So with this system, you'll no longer be a cripple. Fantastic. If you are using Emacs, worth learning. So stuff like this, am I using a Vorak keyboard layout? So if you don't know, this is fairly advanced keyboarding for those of you who work with computers day and night, and you become a cripple because your hand have pen or mouse stuff. Are you seeing me? Yeah, my mouse, my keyboard, okay, so there you see Svalbard, beautiful. This is advanced, very advanced device. So I'm using Sapphire keys, Emacs, and I'm using a Vorak keyboard. So for those of you who don't know, go to layout section, and you can see everything you wanted to know about keyboard layout. So you can see this is a standard QWERTY. Then you can have Vorak, you can have Cormac. So you can see the circle shows the frequency of that letter in English language. So you just search for ergonomic keyboard layouts, xali.info. You'll find this page, and you can see when you switch to Vorak, all the most frequently used keys are on the home row. So that's why it's efficient. So I'm using Sapphire keys, I'm using Vorak keyboard layout, and Emacs, and everything I type, all the commands will show up on the left side, this pink window, this purple pink window. The command name, for example, end of line or block, that's this key. End of line, press again, end of block, press again, end of block. So you can go, it's like functioning as a page up and down. You don't need page up and down anymore. And if you want to go end of line, you just, press end of line or beginning of line. If you do it again, then it goes to the previous block, next block. So, but you can see all the command names are there. And if you just search for that, you'll find the source code. So if you are using Emacs, there it is, the source code. Oh, page moved because the Brave browser idiocy. I mean the Brave search engine is still, they don't update. So you need to go to this new link. There it is, the source code. So the pink window show all my command calls as I do them. For example, delete that line, undo. So you can see smart delete and undo. And the keystroke on the left, that's the Vorak keyboard layout. That's okay, that finishes my introduction. Shall we begin? Yeah, so Wolfram language, Mathematica, what do you guys want to know? So this is a good time if you want to ask me about this Wolfram language, okay? So by now I have like 100 videos on Wolfram language. So you can ask me about Wolfram language, mathematics, geometry related questions, and the Lisp. Wolfram language is Lisp. It is a term rewriting system. You can ask me about this kind of questions. So let's open a new one, and okay, Sunfly keys, close, show today's talk show, so you can see Wolfram language tutorial. Click there, XR Wolfram language tutorial. You'll find everything you need to know, and download for free. Everything is free today. Wolfram script, where download, okay? So you can download it for free, and all your questions get answered, and start to learn the most advanced programming language, more advanced than any of Haskell, Clojure, Rust, any of the fancy programming languages you ever heard of, like one magnitude more advanced, okay, more high level, that is. Okay, Wolfram language. So I have like 100 videos about it already. So let's begin coding. So today I want to do, so let's see the power of XR HTML mod. You see this, select the whole block. So this is, you see this is a list showing browser. You see live stream in 30 minutes, 7 p.m. San Francisco time. You see, what is the most efficient editing system for HTML? That would be XR HTML mod. You can see right here. Jump right to the source code. Now, so this is XR HTML. Highlight all of them. Do it. Yellow, so you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 files. So it's about 10,000 lines. The most efficient. If you want it, you have to pay, okay? Because for 10 years it's all free. Nobody give a shit, and instead everyone is gonna, how do you do this? Please help me. Thank you so much. I love your stuff. But nobody give you $1 for 10 years, and I've been dying of hunger. And then people are gonna argue, your code sucks. You should do this, you're Lisp, what a fucking idiot are you doing? This should be this way. People comments on GitHub, they do it all the time. You are just, a pawn of the open source. So it's no longer free. Pay to get it. But it's still open source. It's GNU GPL, okay? So that is, I haven't demoed the feature. For example, this list of things showing browser, this list. So I can select the previous semantic unit, which is LI, okay? You can do it again, and do it again. It becomes the whole list, you see? Do it again. So they go by semantic units of the HTML. You can do it again. Oh, then it becomes the entire main thing. So if you delete it, showing browser, it becomes empty. Press a key to go back. Press a key to undo. Press one more time, undo. You see, it's back. Now go to the pink window. You can see undo, which is Vorak keyboard F. So now showing browser again, so you got that. So now we start to do real work. I want to delete that single key press. You see, why one single key press E delete this entire list? Because your cursor is here. So let's suppose there's several blank lines above it. So press a key, all the blank lines are gone. Press another key, that the unit above it is gone. Press another key, you see, then all the blank space are gone. So that is kind of short demo of XR HTML mod, okay? If you like it, just donate, okay? Donate and say you paid. You can find my donation website, xrli.info, and so go all the way to the bottom. Mathematics and everything. Then you got PayPal, and Amazon gift card. Click there, copy paste my email, make sure it's correct. $99 would be nice. Thank you. Okay, that's enough advertisement. Now let's begin the coding stuff. So I want to do this. So that's the introduction. So I want to do. Last time we did. In past month we did hyperbola. There are still more things to do. Okay, let me read the comments first. Here's some Coke. Diego says, in stuff like this, when you start a search, how do you jump to next occurrence? Arrow keys, my friend. So this is Coke and this is tea. Very busy drinking. Why do I drink both at the same time? Because Coke that's sweetened sugar drink. So my teeth is bad because for 15 years I don't have money. I haven't seen a dentist. So what you do to counter that poverty is you become very careful. You brush your teeth after every meal. Every time you drink sugar drink, you rinse your mouth or sip tea, because tea is the antithesis of sugar. A little tip for you American health concerned guys: diet, dinosaur diet, and lion diet, carbo diet, Diego diet, something diet. They're doing YouTube every day, like 1 million followers. These idiots. Life is too good. Life is too good. That's how you have this 1,000 diet obsession thing. How do I lose weight? How do I be healthy? You can be very healthy by stop eating, basically. Just eat the minimum. So the question about search. So let me demo. So press a key to search. Now let's say I want to search curve, C-U-R. Okay, there you go. You want to find the next occurrence, right arrow. You see, right arrow, right arrow, right arrow. Previous, left arrow, left arrow, left arrow. So you can jump around. You see? Okay, cancel. What VS Code theme is this? This is not VS Code, this is Emacs. Why do people use Emacs? Is there anything else? Okay. Hello, is there anything? Well, VS Code, you can use VS Code, okay? I want to learn how to use VS Code shortcut. Okay, yeah, do it. Show us Dr. Scheme. Elm is fancier. Idiotic questions, okay? Okay, I'm not gonna talk about Lisp. Dr. Scheme is a Lisp which became, Dr. Scheme is Scheme Lisp, which became Rocket Scheme Lisp. Racket. Okay, R-A-C-K-E-T. That's basically a variation of the Lisp scheme programming language, and I talked about it a million times in my past video. Elm is Elm. Like you don't have a question. I don't think you have a question. You are just like, Hong-san, what do you think about whatever random things? Mo says, I'm starting to appreciate Lisp more since Tree-Sitter uses a variant of Lisp. Oh, does it? That's interesting. Yeah, Tree-Sitter is very good, but I haven't got to. I think I'm too old. I'm too old for anything. The time I have, I need to learn Lean proof system. But Triciter is something I'm going to get into, okay? So let's just start to do something I want to do, I need to do, because I need to update this. So let's go to parabola. Let's quickly do something parabola, maybe. Okay, showing parabola. So you got to see, we did this, several videos in the past month about, parabola optical properties. We did this graph live. Here's the code. You see optical properties of parabola for your car lamps, for radio telescopes, for your dish, satellite dish antenna, things like that. This is alien technology. Wherever there's a UFO alien movies, they'll show these parabolic dishes. This amazing. So if you want to do rocket science, you gotta learn these basics. And we did this evolute of parabola. Okay, let's finish update some of these. You see these tiny little images from 30 years ago. So let's go to top, search.mb, open it. So go to the directory. So this is a Wolfram language notebook.mb, okay? Open it, you can see, let me show you some interesting, okay? So you can see it's Wolfram language desktop 14. Let's just open it first, okay? So you can see here's a notebook. This is like from 30 years ago, 1995, okay? Last update is 2000. Actually, we updated many of these last week. So my job, let me repeat, my job is to remove some, basically delete this notebook, remove the code, and generate new graphics, move the code to the website, okay, and generate new graphics, replacing the 30 years old. So today, let's do this one, pedal, okay? So why am I moving, so then delete this notebook? Why? Because time changed, back 30 years ago. 30 years ago, you go to a website, you have, you use desktop. There's no phone yet. So you download this notebook, you have Wolfram language installed, Mathematica, you run it, you do whatever, enjoy the mathematics. But today, most people don't have a notebook. The Zoomer idiots, they don't know what is a notebook. They don't have. They just have their phone, So, and nobody like download a package, Well, I mean, if you are a professional programmer, you still do, but most people, so it's better just have code. You copy the code, you go to the Wolfram website, then you can paste the code and, stuff. So that's why I need to update, I'm doing updates. So, but one extra tip more if you are watching this. 2 days ago we did a video about the harm of the Unix concept of line truncation, line-based computation, pervasive harm. Okay, now here's a real example. You see this? Let me make a copy. Okay, so let me just make a copy. Copy it. New notebook, Control N, Control V to paste, okay? Now, let me do it again. Now, Control Shift I, okay? So you see, normally, in a programming language, this is what you see. This is familiar to all of you, right? But in Wolfram language, for example, this negative square root 20, okay, let's magnify to see the full glory of this beautiful code. Negative square 20, square root. But I want to typeset it, to the typical Unix, Linux idiots, fanatics. They'll say, use LaTeX. LaTeX is the best thing. It's a standard, LaTeX. But if you want to do LaTeX with the simple square root, you're gonna have like backslash braces, square something, fuck, it doesn't work, wrong syntax, fuck you up. The Donald Knuth idiocy. That's the legacy of the Donald Knuth idiocy. in Wolfram language by Stephen Wolfram. This square root bracket, 20. If you want to typeset, Shift Control N. Can you see that? Oh, beautiful. You don't have to worry about LaTeX micro adjustment. Oh, I need to move this a little bit bigger. Fucking idiocy. Okay, I'm starting to get into a rant. That's no good. I need to just work on this. Okay, but let me quickly show you a rant about LaTeX, because I haven't mentioned it for a while. Okay, the tech pestilence. Why TeX and LaTeX sucks. By the way, for you younger generation, this TEX is pronounced TeX. Okay, it's not TeX. It's not TeX. It's not TeX. It's TeX. That X is pronounced CH. Kind of. Okay, that's what Donald Knuth says. Okay, that's what it's supposed to be. LaTeX, TeX, and LaTeX. Okay, so that so for example, these are the typical typeset mathematics. You have sum, you have succeed, integral, definite integral. You have infinite sum. You have definite and derivatives. You have limits. Then you have square roots. You have the conjugate. You have matrices, right? Very common and square, right? So this is a typical math typesetting. This is basically the fundamental. Okay, like 90% of math typesetting are just these things. Okay, so if you want to do this in TeX, this is what you have to write. This idiocy, this \sum underscore braces n equals 1, correct, k \frac braces 1 braces n. This fucking complete idiocy. But if you want to write the same thing, so that's just for the sum. That's the first one, okay? If you want to do it in Wolfram language, this is what you write, okay? Let me magnify so you can see the full glory, okay? This is TeX, okay? To do this sum, the first line, sum greater than this integral, okay? So this is TeX, and this is Wolfram, okay? Sum 1 over n, and the argument is n from 1 to k. And this is computable. Let me copy it and paste. Let me show you. Paste. Okay, that result is actually harmonic number. So, but let me do it again. Shift Control N. You see, beautiful summation. And by the way, let's do this whole. Okay, so Shift Control N. You see, now it's readable. Okay, let's undo. You see, this is before. This is before, and this is after. Okay, it's like much more. It becomes readable. It reads to you, and you have on-the-fly formatting. Can you see that? On the fly, it adjusts these complicated typeset expressions on the fly, like the second, the microsecond you change the window size, it adjusts on the fly. It line wraps at the appropriate places. And indentation, look at the indentation. It indents at the right place. Artificial intelligence before the ChatGPT Python fuck was born. This is available since 1996, Wolfram language version 3. But if you're gonna do this in Python, like return, indent, return, how many indent, then the LaTeX fuck. Normally there's no problem, because tech progresses. You have different people creating different things. Donald Knuth offered his tech free, right? But then comes these Unix fuckheads, then the open source fanatic fuckheads. They insist, they don't just say, "Oh, I'm used to this, so I don't know about Mathematica. Mathematica, you have to pay. I'm poor right now. I'm a student, so I just use tech." That's not what they say. If that's what they say, that's okay, no problem. I don't have a problem. But these Unix and Linux and these open source fuckheads, they will tell you, insist, tech is the best thing. If you mention, Wolfram language, they'll say like, fuck you. But they never seen what is Wolfram language. They haven't seen yet. They don't know. They don't know. They tell you Python is the best thing. How dare you disagree? Unix is the best thing. C is the best language. It is that triggers me. Okay. But anyway, too bad I got into the rant. Okay, so you see, this is more generally, this is a harm of phonetism. Okay, not just Unix and C or Python or TeX, LaTeX. It's more general. Phonetism in anything creates harm, including Lisp. Lisp people. There's Lisp people. I attacked it enough, so it's harmful. So you don't want phonetism. So okay, so that's about tech. Okay, so let's go back. Let's relax and quit the rant mod. Exit the rant mod and go back to harmony, like this harmonic number. Harmonic number. By the way, this sum is very interesting because if you go to Wikipedia, look at harmonic series, so this is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So will it increase infinitely or will it stop, like the total is like finite? That's a question. Very interesting. This is like the representative of calculus. That's what you do in calculus. This is like, in fact, this series, you could say, is the representative. Like the calculus is entirely about this thing. Whether you add a bunch of number, will they increase to infinite or will they, like, there is actually become a number? So the heart of calculus. And so you can see beautiful graphics, these limits, and then there is this thing. Okay, this thing, very interesting. You stack up a bunch of blocks, and what do you want to do? You want to see if it falls or not. Okay. I'm too old. Okay, I studied this like when I was young, 30 years ago. 35, in 1992. So I was like so excited, I'm studying in this in depth. Why would it this way or that way? So, but now I don't know, I don't remember, okay? But so that's for you young people to study, okay? So we digressed a bunch, so let's regroup, okay? So I was coding some Emac Lisp before. Okay, let's close that. Go back here, close that. Go this page, today's talk show. Okay, let's go back to what we were doing. Yeah, parabola. Okay, so let's go back. Yeah, so notebook. So this is Wolfram notebook. We demonstrated TeX and LaTeX. So let's put the link here and let me answer some questions, and maybe that will be today's topic. Maybe actually I'm gonna do some code. Okay, I need to do at least one LaTeX. I mean, not. I mean, at least one geometry parabola stuff. Okay. Okay, so we talked about, so very interesting topics, harmonic series, and okay. As a Zoomer idiot, I'm offended. Me too. Me too. Diego says, the Unix pestilence, indeed. YouTube says, you use mouse to copy paste. No, I don't use mouse to copy paste. What are you talking about? Like, well, sometimes, but okay. So you see my system. You see the left side is this ultimate hacking keyboard. So if I want to copy, I press this key. You cannot see, but okay. So you can see this key is copy. When I press that, it does actually Control C on Vorak layout. This is cut, this is undo. So one single key press. So I put my hand on the left, over here. So I just operate. So the mouse moves around and my left hand can copy paste and, stuff like that. You are pretty new. This hi Anon YouTube channel. You are pretty new because I talked about this 1 million times. T is Greek letter tau, E is Greek letter epsilon, and X is Greek letter G. Yes. And Mo says, interesting, properly pronounce it. Yeah, TeX. I'm sure LaTeX Wolfram equivalent has its own notation. You can probably see it in the notebook's code behind. Yes. I mean, so if your question is how does Wolfram, for example, this part, it shows, it renders it very beautifully. But the source code is actually just this, okay? Let me just use a simple example. Let's see, do I have something more complex? No. Okay, let's just pick this. So if I paste that, the source code, so Control L to copy previous, Shift Control I to turn it into the input notation. This is actually the source code for that. Okay, they are equivalent. Like for example, I can compute it. Control Enter. Shift Enter. Shift Enter. Shift Enter. Okay, so that simplifies to 2 over square root of 5. So if you want a numerical result, you say n, close. So you say shift n, so bracket, then percent means the previous output, okay, or you can just copy it. So Control L to copy the previous output. So if you want numerical result, just put an n before Shift Enter. So that gets you that 0.89 something. Same thing here, Shift N. So if you want numerical result, you //n postfix notation. Shift N, Shift Enter, 0.8. So my point is that this is the actual source code for this typeset expression. Okay, you can convert it either way by pressing a button, whichever way you like to see it. So when you code, you can just code like that. When you are ready, press a button, it becomes like that. If you want to print it like an academic representation, academic paper, then you show it, you show it like that. Okay, so the other question is, how does Wolfram language actually kind of implement this? Well, yeah, so there is, you can see that by, let's go to a notebook. Let's just save this, okay? For example, this one is simple enough. Let's save this, untitled 2, let's say XX2. Okay, save it in desktop. Now let's go to desktop. Okay, so XX2, open it. This is, we are seeing the raw notebook source code. So this raw source code is like text. Okay, Wolfram language is entirely text. So in notebook it shows like that, but in source code it's just text. Okay, so now you see this raw box. You see this raw box data cell. You see the entire thing is a notebook. You see this line, goes back, goes from top to bottom. Okay, so I can select it. So this entire thing is a notebook. Okay, it represent this, and then above that you see this parentheses and star. Those are comments. Okay, like those are comments and cache. So you can delete it. This, you can delete, like I have in Emacs. I have I'm using Xa Wolfram mod right now. You see, that's another. So I can press a key to delete the entire comment. You see, you don't need it. Okay. So this notebook, and if you scroll to the bottom, then you got cache. Okay. So for example, go down. So end of notebook content, delete that. Internal cache information, delete that. This cell outline, this cell tag, this notebook file outline, you can delete the whole thing. End of internal cache information, delete. Okay, then we got this thing. It's a pure notebook. So you see, the notebook is just this expression. So the Wolfram language, even the notebook entire thing is a Wolfram language. Then, for example, if you create a new file, let's create a new file. Save it as xx3.mb. The entire thing consists of this line. Save it, go to the directory, show in Windows browser. Wait, I already opened it. Okay, too fast. Okay, let me show in Windows browser. Wait, wrong key. So show in Windows browser, so you can see there it is. So XX3, you can open it. It's just empty. Okay, so that represent, so the entire notebook syntax is just text. Okay, so now the thing about this, you see, but over here we are seeing this. Let me do a screenshot first. Okay, hold on a second. So I do a screenshot, so I have a record of what we were talking about for my talk show. So let's go to talk show here, and let's move the screenshot here. Press. There it is, showing browser. There it is. So we can see what we talked about. Okay, but now let's just delete this. So now it's more simpler. Okay, now Control S, save it. Go back. Let's go back to the notebook. xx2.mb has changed. Save anyway. No. Okay, because we just saved it from Wolfram language. Now save it. No, God. Let's go here. Okay. Now close this. Don't save. Okay. Close. Kill anyway. Yes. Okay. Now refresh. Now you see it's much smaller. Now open it. You see it's much smaller, but you can see the square root there. It's still complicated. So anyway, my point here is that the underlying implementation for this typeset thing in Wolfram language is this raw box and cell, box data, raw box. So it's kind of similar to math ML. Okay. So for example, you can actually, so raw box is actually a function. So they are like headers, they are like inert function. But you can look at the documentation. So for example, tab H to see the documentation in XA Wolfram mod. So there it is, the documentation for this raw box thing. So you can see raw box is a low-level box construct that represents a row of boxes or strings in a notebook expression. So this typeset thing are internally represented by this raw box thing. So for example, this raw box, this represent A plus B plus C. So it's in a sense, so you can see it's like the entire notebook is just made of the Wolfram language, programming language. You have these raw box, they are inert functions. They are functions that doesn't do anything. They are kind of just a markup like HTML, H2, H3 or whatever. They are kind of just markup inert functions, but they are functions nevertheless. So, but when you display this source code in Wolfram notebook, these raw boxes, they become rendered just like HTML. Okay, that's how you have this. Okay, but again, these are kind of implementation issues. You don't need to know. All you can, all you need to know is just type this, for example, type this sum and press the button and it becomes like that. Okay. You don't have to know this raw box and stuff. Okay, that's kind of that. The other major problem with TeX is that they are not computable. So it's like what it's the most idiotic shit. Like it's not just my bitching. Like what this is a major issue. Design. Donald Knuth is a genius. I mean not exactly a genius, but he's a very high IQ, one of the most accomplished computer scientists and math-oriented computer scientist. So he's one of the great mathematician. But that doesn't mean everything he creates is great. So in the computer, he wanted to do typesetting. When there's no typesetting for computers. Back in 1970s, right? So he are designing a system to do typesetting. But how? I don't, somehow he created this language that cannot compute. I mean, it can compute, but I mean, if you want to do, let's say, squared, let's say a number squared, let's say 2 squared, okay? So if you just want to do, let's say, x, let's say 3 to the power of 2, right? So in Wolfram language, you just copy that, do that, type it, and you got 9. But in TeX and LaTeX, how do you do the raise a number? So it's the same syntax, right? 3 correct 2, but you cannot get 9. It's like it's only for display. Like what the fuck is he thinking? I don't understand. Does anyone know the history? Like. How did it happen that Knuth, one of the accomplished mathematician and computer scientist, creating a typesetting language, but he forgot, he doesn't know, he never thought of to make the language like actually can compute mathematics, because all these sum integral, they actually represent computation. They are just notations. So I guess my guess is that back then, To us today, it seems obvious, right? Obvious. But back then, there's not many, there's no internet, there's no, not much of anything, there's no Python even, right? You got C and Pascal. He wrote TeX in Pascal, right? So back then, his focus is to create a typesetting system. You can, so that is a big task, that's like probably a big, huge task. Nobody has done it before. So that was his thinking. I need to create a system so that x squared, this 2 will be smaller, typesetting. So he didn't, he not like today. He's not thinking, oh, why don't we just make it also can compute? That's like we are not there yet. So yeah, but so I suppose that's why. But so again, what pisses me is that today, even 10 years ago, 20 years ago, this you go to Stack Overflow, you talking to the Unix people, the Python, like they say tech, but they don't they never thought of these problems. Why can't you compute it? This sum, for example, I type this, let me demo again, this in Wolfram language, okay? I type this, let's say, okay, so I copy it, Shift Control N to make it typeset. I can compute it, okay? Shift Enter to compute it. Shift Enter to compute it. Okay, now this sum has a symbolic result called harmonic number, okay? But let's change the variable so it becomes actually something. Let's say 1 to 9. 1 over n sum, n from 1 to 9, okay? Shift Enter. Can you see that? Now, copy the input, Shift Control N to make it typeset, and Shift N to compute it. Can you see that? That's what I mean. That's what you are doing in mathematics. Why are you writing this for? You are doing mathematics. Is it important to actually not just typeset and compute a number? Yeah, it's of course, obviously. So these people, this like 1,000, like every time I talk to them, they don't listen. They attack me. Like this Tech Pestilence article is back from 2004. Okay, I wrote this article 2004. Then the bunch of idiots, they LaTeX, Unix, the fuck them. They don't understand what I'm saying. They attack me. The guy is a troll. He's just trolling every day. Fuck, let's ban him. They did lobby to ban me from the news group back in 2005 also. I wrote this article. So there's a documentation of the fact. Ban Xali. You can find it. Just search for that on xali.info. So I complain. I say these fucking idiots. Like every time I talk about Unix, I do rant on Unix C or, they and Python and Perl or Lisp, But you got this phonetic, this code. Unix is a code. Python is a code, is codey. Emacs is codey, very much. Emacs, okay? Emacs is very codey. Python, Unix, and TeX, okay? So every time you mention something maybe sensible, they will attack you to no ends if you are loud like me. I don't say, hey guys, have you thought about this? Maybe it's wrong. Can we possibly have a TeX do also computation? That's not the way I talk. The way I talk to them is, you guys are fucking idiots. That's it, So they ban me. They say I'm troll. They have no idea what I'm talking about. That in all these groups, what groups are not code? PHP. JavaScript in the beginning, Pascal, the programming language Pascal. Okay, like some programming language, they don't have a code. PHP, for example, everyone beginner loves, because every time you ask a question, you got an answer. People will help you. But in Python, in Lisp, in Haskell, every time you ask the question, everybody else is gonna do, you shouldn't do it that way. Oh, have you thought about monad? Have you thought about iterators? You shouldn't, fucking fuck them. Okay, so this end up so how long have I been? So I got 8 more minutes. So let me actually want to do a Wolfram language code. Okay, so let me do that. So there's one more question. Let me answer that. So you are going to do a stream about Wolfram language 30. Maybe, but you see the issue. Wolfram language 30. I mean the Emacs version 30. Okay, Emacs version 30 came out, and you can see on my blog there is Emacs 30. Okay, so Emacs 30 came out. Emacs version history. I recently kind of updated this page, history of Emacs. So you go to Emacs 30, then you can read the entire Emacs 30 feature list. They call it news. That's a Emacs tradition. Emacs news. for 40 years, that's how they go. They don't say release notes or feature list. No, it's Emacs news. Emacs news 30. So usually every Emacs major release is like 1,000 pages. I mean, a few hundred pages, and so it's 10 years ago. I sometimes I went through and write a nice blog, so you can read and you can actually understand. Oh, this is new. But I haven't done that for a long time, because this is takes a week to take more than a week to go through each one of them, and they are written usually in a way it's not understandable. Okay, even if you are a Emacs coder or user for 30 years like me. I've been using Emacs for 26 years, okay, since 1998. So usually they are hard to understand. So if, for example, click on this. So what does it say? New value if regular for replace argument to insert file contents. Okay, I know insert file contents is one of the function. So new value if regular for, okay, so they added a new argument to this function. Okay, that's one item, so it's kind of esoteric, and here, for example, new haiku specific variable, haiku pass control tab to system. I don't even know what that is. Haiku is some kind of a text rendering system, something. So this sets whether Emacs should replace C tab, control tab on the system instead of handling it, fixing problem where Windows switching would not activate if Emacs frames something. Oh, focus on the haiku operating system. Fucking shit. That's esoteric among the esoteric. You see, haiku is the operating system. So this is talking about on that operating system, then Emacs has this change, that what the fuck, so who knows what the fuck is haiku? It's like one in a billion, that like nobody uses haiku, so that's kind of like, this Emacs news, so for example, this one XLFD. are no longer restricted to 255 characters. What the fuck is XLFD? Font XLFD name now returns an XLFDE even if it is greater than 255 characters in length. Font. So is that a font? Very esoteric. You see, that's the nature. So, if I'm gonna, so it is hard to like summarize what's relevant news to relevant to the user. So you gotta go through this. So I'm not likely gonna do a blog, a live stream about Emacs 30. What's new? There's another guy who is doing it. You might watch. I don't think he's doing video, but he's got a blog. Mastering Emacs. Okay, this guy is kind of my nemesis. Okay, so there it is. Okay, Mastering Emacs by this guy. So he usually, after each new Emacs version, he actually gives you a summary, a readable summary for the user. What's new? So there it is. What's new in Emacs 30.1? Okay, so artwork. Then you see, so this is like 50 pages. Even even reading this, his summary is 50 pages. Okay, but you can check it out. Okay, so this Mastering Emacs guy, he's a Northern European. What's his name? His name somewhere, okay? But he's on video. Sasha Chua, another very well-known person in Emacs community, Sasha, she interviewed him, this guy, on video, so about 15 years ago, so you can watch that. So anyway, Mastering Emacs. So one last thing. So let me just I want to quickly code one parabola, okay, and that will be it. So what's going on here? So hold on a second. Shrink. Okay, so what I want to do with this, I want to just copy this, okay. Okay, got the image, close that, don't save. And let's quickly do one of these update I need to do. And that's it for today. Thank you guys for watching. Where is the one I want? Okay, here, I suppose. Okay, so back to the browser. Am I alive and kicking? Is my video? What? What? Close that. Why can't I close this? Close that. Close that. Okay. Okay, my keyboard is not working correctly. Shift, Control, Window. Okay. I have sticky key on, so when you have sticky key on, sometimes it's mysteriously stuck. Fuck, I don't understand what's going on with that. Okay. Okay, so finish this. Okay, so yeah, so close. Notebook, close. Okay, so notebook, you gotta, okay. Let's copy that. Actually, copy. Okay, close. Show in browser. This is today's talk show. Go to parabola. Yes. Yeah, and go to parabola. And the graphics we want to do is this. Okay, so this one. So pedal with respect to its vertex. Okay, so pedal a parabola. Yeah, okay, there's more. So let's copy that. Copy a new paste and copy. Okay, make it typeset. Kind of copy that. So search for pedal. Okay, so here is the graphics. Here's the old one, very tiny. So the new one needs to be here. So start a Wolfram language code. So yeah, so the parabola formula, that's the code, but we have we can use this. Okay, so the parabola is actually just that. Okay, so replace that by that, and from t from -9 to 9 in increment of 0.5. Yeah, let's leave it. Okay, then curve color function. How do you want the curve colored? Leave that. And we need this part. This is my package, and let's rename this paraplot to plane curve plot. Okay, plot this equation, parametric equation, x equals to t and y equals to t squared divided by 4. Okay, -1 to 9 to 9. Okay, pedal points, hue, that's curve color function. Okay, automatic aspect plot range. Okay, that's it. So copy, go here, select all, paste, run it. Beautiful. Okay, so we just gonna, so let's just copy this. So this is the, you are seeing the pedal curve of a parabola. Okay, now if you want to know what is a pedal, you have to read my website. Go here, you can read about pedal curve. There's detailed explanation and steps, 4 steps. So we got the correct formula. Let's delete this part, put it back. Then we did a screenshot, press, move the image here. Okay, well, that's the other one. Okay, let's do it again. Okay, that's the other image. We need to, okay, do it again. So that's the one we want. Okay, rename it parabola pedal. Okay, do it and update it. Okay, now we got these 2 images. This should go to my talk show. Copy the file path, go to the talk show, show in browser. Yeah, here. So paste the 2 file path. You can see, make an embed image, make the embed image. So open that. So that's what we talked about. Wolfram notebook raw source code. And here's a summation. Let's rename it Sound Talk Show. Okay, and move move the file to the current directory, move the file to, what did I do? Yeah, wait, what? Yeah, so move the file to the current directory and rename it Talk Show. Okay, regenerate this HTML, and this one Talk Show, regenerate it, show it. There it is, Talk Show. So we talked about these things. Now go back to the parabola page. Open this, it's gone because we moved the image. So delete that. Open it, it's gone because we moved the image to a different directory. Delete that. So now we got this new thing, okay? And here's the code. Show in browser. Go down. Down, 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 down. There it is. That's our new image, and here's a code. We need to color, syntax color it. Do it. Back to browser, refresh, beautiful. Okay, and this old image, delete it. This one, tiny, 30 years ago. Delete, gone. Okay, so yeah, remove the tag. Now cut this line and move it to the figure caption. Paste, back to browser, refresh. There it is. Okay, did we actually... Anyway, that's it. Bye, guys.